Welcome to the Academy today. We'll be dealing with measurements and bounds, a wonderful topic. Let's get into it straight away. Sometimes we have a number presented in rounded form or an estimated value. So if a number is expressed in a rounded form, we may need to think about the two extreme values known as bounds that are used to describe all the possible values of the number. These extreme values, once again, are known as bounds. So we're looking in this video at how to find these bounds and then describe the error interval for our estimated value. All right. Now, the lower bound is the smallest value that would round up to the rounded or the estimated value. Another word for the rounded value is the estimated value. Estimated. So we can get the lower bound, the smallest value that would round up to that estimated or the rounded value. That is what is called the lower bound. Now we're going to see how to find out in this video. The upper bound is the largest value that would round down to this rounded or estimated value. The largest value that would round down, that is the upper bound. Now, to find the upper and the lower bounds, we use the possible error obtained from the given degree of accuracy. So we must get the possible error, and that possible error, we're going to find it from the given degree of accuracy. So let's see how that is done. All right, for which I'm going to have to take this traces away. So we have the error interval is given by half the degree of accuracy. So we go straight off with degree of accuracy divided by 2. This gives us the error interval. So we want the error interval, the degree of accuracy divided by 2. We give us the, let me describe this as the possible error. This is best described as the possible error. So I'm taking this away and I'm going to call this our possible error. So we have to find the possible error first. The possible error is what I need to describe it, the possible error. Yes. Once the possible error is known, then we can find the upper bound and the lower bound as follows. Let me use another color of highlighter to show that. Now, we can simply find the lower bound. So the lower bound, first of all, the lower bound is given by the rounded value or the estimated value. The rounded value minus the possible error gives us the lower bound. So having obtained the possible error, we can go ahead and find the lower bound. So by subtracting that from the rounded value, we get the lower bound. In a similar manner, we can get the upper bound. Upper bound. The upper bound is simply given by the difference, once again, between the rounded value, the difference this time around. I have to take that back. The difference is not what is required. The difference is used in the lower bound computation. So this is rounded value now plus, which means we're dealing with the sum this time around, plus the possible error. The possible error. So by adding the possible error to the rounded value or the estimated value, we obtain the upper bound. And by subtracting the possible error from the rounded or the estimated value, we have the lower bound. Beautiful. Now, once we have the lower bound and the upper bound, then we can describe what we call the error interval in an inequality. So let's go ahead and take these traces away so that we can describe the ultimate expression in this lecture, which is the error interval. Okay, so let's describe the error interval. Now the error interval. The error interval. The error interval is simply this inequality. We have the estimated value the estimated value lying between. Oh no, that is not going to include that. So I'm taking that away. Beautiful. So this is what we've got. The estimated value lying between the lower bound and the upper bound. Lower bound and the upper bound. Beautiful. Now this is what we call the error interval. As you can see, the lower bound is included in the inequality. The estimated value is greater than or equal to the lower bound, but certainly less than the upper bound. So this is the error interval. That's right. All right, so let's move on into some illustrative examples now. All right, so you can pause the video and take notes as appropriate. Let us move on once you have done that. Okay. All right. Traces have to go. Okay. Now, in our first example, we have the length of the page of a book is measured at 45 centimeters. Find the lower and upper bounds for the length of the book. So measured as 45 centimeters. Can you see that? Good. Measured at 45 centimeters. So we are now going to use this. We will be given the degree of accuracy. This may be to the nearest centimeter. If we measure this to the nearest centimeter, the length of the page of a book is measured as 45 centimeters to the nearest centimeter. So we have the nearest centimeter. It is measured to the nearest centimeter, which means to the nearest 1 centimeter. Now we can get our possible error from the degree of accuracy. This is the degree of accuracy this time around. So taking this as the degree of accuracy, 1 centimeter, because we're measuring to the nearest centimeter. 1 centimeter becomes the degree of accuracy. Degree of accuracy. Beautiful. So we can have our error interval. Let's go. Now the possible error. Remember, the possible error is simply the degree of accuracy divided by 2. So that's degree of accuracy, which is 1 centimeter, 1, divided by 2. And that gives us 0.5 centimeters. With this possible error, we can find our upper bound and the lower bound. So let's see first of all, the lower bound. Lower bound is simply the difference between the estimated or the rounded value, which is 45 centimeters here. So we have 45 centimeters minus our possible error, which is 0.5 in centimeters, of course. And this gives us 44.5 centimeters. That's right. And now we can also find our upper bound. The upper bound is now going to be the sum. So we have this is going to be our estimated or the rounded value once again, 45, added to the possible error plus 0.5. All of this in centimeters. And of course, that gives us 45.5 in centimeters. That's right. So we have the upper bound value and the lower bound value. Very, very simple. That's interesting. Very interesting. Beautiful. Let's look at the next question, for which I have to take the traces away. The length of a field is 125 meters. Can you see that? Measured to the nearest 5 meters. 125 meters. And this measurement is to the nearest 5 meters. So the nearest 5 meter becomes our degree of accuracy. Let us determine the possible error straight away. The possible error. And that is what we're going to use to find our bounds. The possible error is simply the degree of accuracy divided by 2, which means 5 the degree of accuracy divided by 2. And that's going to give us 2.5 centimeters. 2.5 meters, because we have that as the unit of measurement. The possible error is 2.5 meters. With this possible error, we can find the lower bound and the upper bound right away. Now, straight off the lower bound, we simply subtract this possible error from the estimated or the rounded value. So the rounded value, once again, 125 meters minus 2.5 in meters. And that gives us 122.5 in meters. This is our lower bound. In a similar manner, we can find the upper bound. So the upper bound, by addition this time around, the upper bound is going to be addition this time around. So we take the rounded value, 125, rounded or estimated value, and add to the possible error, plus 2.5 in meters. And this will, of course, give us 127.5 in meters. Now we can show, by extension, we can show our error interval. Now the error interval can easily be written. We have answered the question right here. We have answered the question. That is the value of the lower bound, and that is the value of the upper bound. Very simple. But we can, by extension, describe the possible the error interval. Let's take the error interval. So we have the error interval. The error interval. We can write the error interval this time around. We're talking about the length of a field. So length of the field, which I will simply write as length of the field. Then we use our inequalities now. Position the lower bound on the left-hand side. Lower bound, of course, 122.5. 122.5 centimeters. Is it meters, of course? And then the upper bound, 127.5. So this is the error interval, 127.5 in meters. Very simple right there. That's good. Okay, it's getting interesting. Let us go into the next area. Trace this out of the way. Now here is another question. The mass of a bag of potatoes is 30 kilograms. Measure to the nearest kilogram. Find the lower and upper bound for the mass of the bag of potatoes. Let's see. So we have our rounded value. Our rounded value is already 30 kilograms right there. Our rounded value, 30 kilograms is our rounded value. Now we're measuring to the nearest kilogram, which means the nearest 1 kilogram. That's the meaning of the nearest kilogram. Nearest single 1 kilogram. And that becomes our degree of accuracy with which we can find the possible error. So straight off, the solution becomes find the possible error, First step is to get the possible error established. That leads us into the bounds. The possible error, half the degree of accuracy. So that means degree of accuracy, 1 kilogram, divided by 2. That's going to give us straight away 0.5 kilogram. That's right. This is the possible error. Now we can find the lower bound. The lower bound. The lower bound. The lower bound is simply the rounded value, 30 kilogram, minus the possible error, which is 0.5 in kilogram. And now we obtain 29.5 in kilogram. Beautiful. And we can find the upper bound in a similar manner. The upper bound is given by the addition this time around. We have the rounded value or estimated value, 30, added to the possible error, which is 0.5 in kilograms. And this gives us 30.5 in kilogram. Very simple. So we have the upper bound and the lower bound. Once again, we can find the error interval here. to find the error interval. So the error interval, Now we may learn how to use symbols. Supposing we represent the mass of the bag of potatoes by a symbol M. We want to represent the mass by M. So we can simply write the error interval in form of the symbol M, and then set up the inequality. Lower bound on the left-hand side, 29.5 kilograms. Upper bound on the right-hand side, 30.5 kilogram. And that settles it. Very simple calculation. Let us move on. All right, we have another example. The result of a computation is expressed as 7.2 to 1 decimal place. 1 decimal place. Now find the lower and the upper bound for the result. Now, because we have 1 decimal place, we can simply infer that our degree of accuracy is the 0.1 unit. So degree of accuracy from this statement, 1 decimal place, is 0.1, the degree of accuracy, 1 decimal place, which means 1 digit after the decimal place. That means we can easily get a possible error from there. So the possible error, is going to be half the degree of accuracy, which is 0.1 divided by 2. And that settles it, 0.05. And that becomes our possible error. With this possible error, we can now find our bounds. First, the lower bound. Lower bound is now going to be the rounded value or the estimated value, which is 7.2. 7.2 minus the possible error, which is 0.05. And that's going to give us, of course, 7.15, our lower bound. We can also find the upper bound in a similar manner. The upper bound is going to give us 7.2 plus 0.05. And that gives us 7.25. Very simple. So the actual value in this computation ranges from 7.15 to 7.25. These are the acceptable values. That's the basic idea of bounds. Let us proceed to the next question. But before then, it's important to subscribe to this channel. 2 important steps that have to be taken now. Subscribe to this channel, turn on this notification bell so that you can be alerted anytime I make videos of this quality, of this nature. You learn a lot of things from these videos. So subscribe and then share this video so that others can learn. All right, let's move on. Thank you for that. Okay, we're in another line of our learning. Okay. We have a computation, series of computation. If A equals 6 centimeters and B equals 8 centimeters, then A equals 6 centimeters, B equals 8 centimeters, and both of these to the nearest centimeter. That statement gives us the degree of accuracy already. Nearest centimeter means nearest 1 centimeter. That's the degree of accuracy we're going to use in this calculation. Find maximum possible values. Maximum, we're interested in maximum possible values of all of these. So the first thing to do very quickly now is to find the upper and the lower bounds. So let's first of all get our possible error in place in the solution. So let's get our possible error in place. The possible error, possible error. The possible error is going to be the degree of accuracy divided by 2, which means 1 centimeter divided by 2. And straight away, 0.5 centimeters. We have the possible error. Now we can have the lower bound. So straight up, lower bound. The lower bound is going to be given by subtraction, the rounded value for A. So I have to group this really. There are two values here, A and B. So lower bound for A. Let's go. So I'm going to take this out of the way. Lower bound for A. Lower bound for A is going to be the estimated value for A, which is 6 centimeters, as we can see, minus the possible error, which is 0.5. And that's 6 minus 0.5 gives us 5.5. And we can refer to this lower bound for A as minimum value of A. So I can simply say, therefore, A minimum is that value. But let's be patient with that. Let me also obtain upper bound for A. Upper bound for A. The upper bound for A is going to be, this time around, is going to be by addition, 6, the rounded value or estimated value, plus 0.5, which is the possible error. And this gives us 6.5. All right, both in centimeters, because that's the initial unit of measurement. Beautiful. Now we have this. In a similar manner, we want to obtain the lower bound and the upper bound for the B value. So we go straight off lower bound for B. Lower bound for B. And that's going to give us the rounded value or estimated value for B, which is 8, minus the possible error obtained, which is 0.5. And this gives us 7.5 centimeters. Finally, the upper bound for B. The upper bound for B is going to be given by the sum. This is 8 plus 0.5. And this is going to give us 8.5 centimeters. Now we can summarize our values ready for the main calculations. So we have lower bound for A, and we like to refer to that as A minimum. Lower bound, the minimum value A can have is 5.5. 5.5 centimeters. Maximum value for A maximum. The maximum value, highest value that A can take on, 6.5. Good. And in a similar manner, we have the minimum value for B minimum is the lower bound for B. Of course, we have it, 7.5. And finally, the maximum value for B, so we refer to that as B maximum. That's the highest possible value for B, 8.5. With these 4 values, we can solve any of the questions following. So let us proceed in this area. Correct. Now we have solution to A. Logical reasoning is necessary here. What is the maximum possible value for A plus B? So we're looking for A plus B maximum. What's the maximum possible value for A plus B? The maximum possible value for A plus B will occur when we combine the maximum, because this is an addition. The biggest value of A has to add on to the biggest value of B to give us the maximum. So we're talking about A maximum plus B maximum. Beautiful. And we can choose them from our values here. And therefore, we have A plus B maximum is going to be the maximum value of A. We have it, 6.5. Plus the maximum value of B. Maximum value of B, we have it, 8.5. And this is going to give us the final answer, which is 15 centimeters. That's our final answer here. Very simple. Let us look at the calculation B. We're looking at the maximum possible value of B minus A. So let's go. B minus A maximum. This is a subtraction, and we have to be very careful. If we want the maximum possible value of the difference, B minus A, we have to subtract the maximum value of B must subtract the minimum value of A. Look at that. We want the difference between B and A to be the greatest value possible. So logically, we have to know, we have to subtract. Use the biggest value of B to subtract the smallest value of A. That's when we can get the maximum value. So this will give us B minus A at its maximum will be given by the maximum value of B. We can import that. That's it, 8.5 minus the minimum value of A. And that's it, 5.5. And that gives us straight away 3 centimeters as our final answer. Very simple. Calculation number 3. And that is the product of AB, maximum value of the product of A and B. So A multiplied by B, maximum. And that will give us, can you think of this? The biggest value of A must multiply the biggest value of B. This is a product. So we're talking about A max multiplied by B max. Give us the maximum possible value of the product. And therefore, let us introduce the values. The maximum value of the product of A and B, AB maximum, is going to be given by the maximum value of A. We can input that 6.5. Multiplied by the maximum value of B, which is also 8.5. And this gives us 55.25. 55.25. And of course, we're multiplying A by B, so the units have to be the square units. So we're talking about centimeters squared. Very simple. Very, very simple. Now let us clear some space so that we can see the calculation D, which is the ratio. This is actually a ratio, so let's have D right here. This says B divided by A, and we're looking at the maximum value. You can pause the video to reason. How are we going to obtain the maximum value of this ratio? The maximum value will occur when we take the maximum value of B and divide actually by the minimum value of A. Yes, the smaller A gets, the bigger the result of the division. So it has got to be the minimum value. And now we can finish it off right here. So the maximum value of B, we can pick it up. That's 8.5 to be divided by the minimum value of A, which is actually 5.5. And there will be no unit, of course, because the unit of B cancels out the unit of A, centimeters cancels out. And if we divide this approximately, we get an approximate value of 1.53. 1.53, no units. Very simple. And that settles it for this question. Let us look at the next one. All right. Beautiful. Now we have X is giving us 8.4, Y is giving us 2.2. Correct to 1 decimal place. That's the degree of accuracy. Now find the minimum possible value of each of this. So let's get straight up into it. First thing to do is to establish the upper and lower bounds of X and Y respectively. So let's go straight into the possible error from the degree of accuracy. 1 decimal place. 1 place of decimal, which means the degree of accuracy is actually 0.1. 0.1, the degree of accuracy. Now let's go for the possible error. Possible error in this calculation. The possible error in this calculation is going to be 0.1 divided by 2. And once again, we have 0.05. Beautiful. This is the possible error. And now, we can begin. Let us go straight for the lower bound of x. So lower bound of x is going to be the difference, of course. So 8.4, the rounded value or the estimated value, minus 0.05. And this is going to give us straight away 8.35. The upper bound of x. This is going to be by addition, so 8.4 added to 0.05. And this is going to give us 8.45. So we have the upper and lower bounds for x. We do the same thing to obtain the upper and lower bound for y. So lower bound for y, let's see. Lower bound for y, let's see, by subtraction, 2.2 minus 0.05. And that's going to give us 2.15. And now the upper bound for y. That's going to be by addition, 2.2 plus 0.05. And this is going to give us 2.25, of course. Now the summary of our values in terms of maximum or minimum. The lower bounds represent the minimum and the upper bounds represent the maximum. So we can go straight away to say x minimum is the lower bound for x, which is 8.45. X maximum, which is the upper bound for x, is also given to us 8.45. Oh, I have to take this correction here. That is not intended. I have to take that back. 8.35, lower bound for x. Beautiful, 8.35. 8.45. And now, y minimum, lower bound for y, 2.15. Y maximum, the upper bound for y, is 2.25. And now we're set for the calculations that follow. Let's start straight off with A. We're looking at the minimum possible value. Minimum possible value. So we're talking about x plus y at the minimum. And let's go. The minimum value of x plus y can be obtained when we add up the minimum values of each of these. So we have x minimum must add to y minimum. And that means by substitution of these values, we have x plus y at the minimum. It's going to be, let's import the minimum value of x. Minimum value of x, let's bring it in, 8.35. Plus minimum value of y, let's bring it in also. Y minimum is right there, 2.15. And by adding this, we have, of course, 10.50 as our final answer for the first calculation. Very simple. Let us create that demarcation for more works. The calculation B, minimum value of x minus y. Let's go and look at that. So we're talking about x minus y at the minimum. How can we obtain this? Subtraction. We have the minimum value of x, subtract x minus y. That will happen when we take on the minimum value of x, the minimum value of x must subtract the maximum value of y. of course. This is what can give us the minimum value of the difference. The smallest value of x. X has to be at its smallest to subtract y at its greatest so that the difference is minimal. And this is going to give us x minimum. Let's choose the minimum value of x, which is 8.35, minus maximum value of y, which is 2.25. So you can pause the video to resolve the mystery here. There's no mystery really. It's clear, very clear, easy to comprehend right there. How can this be? We're looking at the minimum value of the difference. So that has to be when the first value is at its minimum and the value being subtracted is at its maximum. Then we can generate the minimum value of the difference. That's clear enough. Let's proceed. So we have, by subtraction, this is going to give us 6.10. Very simple. And now the calculation C, the product. Minimum value of the product XY at its minimum. This is a product. So the minimum value of each of the values will give us the minimum value of the product. So we're talking about X at its minimum, multiplying Y at its minimum. Minimum value of X multiplying the minimum value of Y. So this is going to give us, let's go, and therefore we have the minimum value of X, let's import it, and that is 8.35. Multiplied by the minimum value of Y, which is also 2.15. And this gives us the value 17.9525 when we multiply. Very simple. That's how to handle it. Now the final calculation, which is D, we're looking at the minimum value of the ratio X divided by Y. So we're saying X divided by Y at its minimum. How will this happen? Can you pause the video so that you can think about how this should be handled? Okay, good. If we want the minimum value of this result, we have to divide X minimum by Y maximum. That's logical, because as the denominator in a division increases, then the result of the division gets smaller. So we need the smallest value of X to be divided by the greatest value of Y to get the smallest value of the combination. By substituting values, therefore, we have this is going to be the minimum value of X minimum. Let's pick it up, and that is 8.35 divided by the maximum value of Y, which is 2.25. And by putting this in the calculator, we'll get 3.71. With an electronic calculator, you can easily do that. Our final answer. Very simple. So this is how we solve such a question. All right, we have another question right there. Let's take off all traces for this one. Look at this. Three quantities, T, U, and V, are related by these expressions. T equals U squared divided by V. And U is given already. V is also given, so that we can find the maximum possible value of T. This is a beautiful question, involved question. So let's see, we want to find the maximum possible value of T. Beautiful question. So I would prefer to release this as a short brain teaser question, okay? And then you can go ahead and solve this and then put your answer to this question in the comments. So I'm going to release this as a short brain teaser question. So put your answer to this question in the comments and look out for the video that will explain the solution to this problem. All right. And that's another one. So I'm going to put up this. Now it is your turn to practice. That's the only way you can become an expert, by practice. So practice to become an expert. Yeah. Are you ready? That's the only way you can become an expert. Let's go. Because mastery and expertise are products of persistence and consistency in practice. This is one of my quotes. So now you're ready. Yeah. So question 1 and 2 right there. So solve this. You can pause the video to go through the solution to these questions. Yeah, pause the video and solve this. Keep solving and see. So get your answers. Now, when you're through with solving, you can refer to the answers in the key. So I have the answer key for you only when you have solved. Make sure you have solved these questions. Now, if you have any questions, you can put them in the comment section. Any of the explanations given that you do not understand, and you can make a request of topics you want to be treated in the next video. Just put them in the comment section. Thank you for watching, and please subscribe, turn on the notification bell, and subscribe. Share this video to friends to facilitate learning. You can follow me on all these platforms. You can send me a message or WhatsApp. You can send me an email. So please like and share this video. And until I come your way next time, I'm your special coach. My name is Temple AK. Continue to keep up your practice and stay blessed. Bye-bye for now.